Okay, we just introduce our today's first speaker, Mr. Gaurav Patel, uh, who did his BE from GTU, and then he did his MTech from PDPU. Also, he was a student chapter president for two student chapter, AIT student chapter and PDPU student chapter, and he did fabulous role. He was a quest chapter level champion, participated in all three ACREX during his student tenure. He joined as a technical officer in Germany, handled various solar thermal air conditioning systems. He was a key person in different projects, and also he supported ISHRAE Ahmedabad chapter in various assignments in Equest since 2016. He was also co-chair for advocacy of ISHRAE Ahmedabad chapter in present team. So let we welcome Gaurav. He was the youngest BEE certified energy auditor in present CWC team of ISHRAE Ahmedabad chapter. So it's a really proud moment to welcome Mr. Gaurav Patel. Please, Gaurav.
Good morning, everybody, and thank you, sir, for introduction. Can we wait 3 more minutes because it's not 11 o'clock now? So we wait for 2-3 minutes and then we can start. Or if you want to start now, then we can also start. As
No
per
issue. It's a matter of 1 minute, no issue.
okay. Before starting, let's say we can utilize these 2-3 minutes. Can our participant can introduce or share their questions or anything they want to know in the chat box so that we can discuss on that particular topic also. If it is part of this presentation, we can focus more on that particular topic. So it will be interesting for them to know various aspects. So I request participants, if they have particular concerns, they can comment it in the chat box. So it will be, I don't want to keep this presentation in a one way. So let us keep it two-way communication. You can put your comments in chat box. So we can, it can be an interactive session for both of or everybody participant in this presentation. So I keep this form open and you can comment it in the chat box. I will view it in the chat screen. How many participants? We have 16 participants, right? Or 12 participants. Okay. just we are waiting for 1 minute and then we can start. So as I said earlier, if you want to tell something, you can always write in the chat box during the presentation, or you can raise your hand, or you can question it in the chat box. Shall we start, sir?
Yes.
Okay. Very good morning to all of you. And today I will talk on energy conservation awareness. So this is my LinkedIn profile. If you want to, you can see my mouse cursor.
Yes.
Okay, so this is my LinkedIn profile. If you want to connect me or connect with me, you can send me a request, or if you have any question, you can ask in the chat box, or if you want to ask later on, you can always communicate with the ISHRAE chapter, and later on I can communicate with them, and you will have some clarification on that particular comment if you want to solve that particular topic. So on today's talk, I will talk mainly on the energy resources available with us, and then what is the energy conservation, why it is required. And then I will talk on the energy conservation opportunities in HVAC&R, that is heating, ventilation, air conditioning, and refrigeration. So I will not cover those aspects that you can study by in the book, or you can generally study from your in the semester courses. So my presentation will be out of that particular topics. So it will be new for you to understand the different aspects of the energy conservation. So you will not find that particular resources in your book, and it will enhance your understanding for the energy conservation. So my presentation will be like that, practical approaches for the energy conservation. And in my presentation, I have also some calculations. So while after this presentation, we will do some calculations, two calculations we have. So based on that, you can calculate for your own purpose. So this will be a reference calculation. So we will do together to calculate the different energy saving opportunities in air conditioning. So we'll do together, and then it will increase your understanding of the energy conservation, and you can multiply, you can do it later on also. Now, what is the role of energy in our daily life? So if we see, these are the main three energy that we require other than the food. So electrical energy we required because most of the gadgets are working on the electricity. So it can be derived from the energy resources. That can be a coal, natural gas, solar, or renewable energy. And we required heat energy also for cooking and heating purposes. So that can be also derived from different resources, and for the transportation. So these are the energy resources that we require mostly other than our food and daily requirement. Now, why energy conservation is required? You can see in this figure, this is a power plant. Can anyone tell me in the chat box, what is the normal efficiency of the thermal power stations? So we feed the coal in the thermal power station, and the coal is burned at around 1200 degrees Celsius or 1300 degrees Celsius. So from that energy, it will be converted, water will be converted in the steam. And that steam is utilized to rotate the turbine, and later on it can generate electricity from the generators. So I get the comments 40%, 70% is not right answer. It ranges around 35% to 40%, or latest power plant 45%. So it depends on the kind of thermal power stations. So why this is? So we are giving 100, our input is 100, and what we are getting is the after deduction of the efficiency, we get around 40% or 35% based on the thermal power stations. Now we are feeding 100, we are getting 35 or 40. After that, whatever the power is generated, it will be a step up. Then it will be transferred to the transmission line and the distribution lines. And there are the distribution losses in those distribution lines. So it will be, again, it will be a losses in the electricity or energy. Then it will be transferred to our house. And in our house, every appliances have their own efficiency. For example, if it is a motor, the efficiency level is 90% or 95% based on its model or efficiency range. So again, there will be a losses in those particular appliances. And after that, there will be some other application, then you will get the final output. So if you calculate all these losses, then if you generate 2 units at the power station, you will get around 1 unit of energy at your household. That is the useful energy. So we can say that 1 unit of energy, electricity is saved, is saving 2 units of energy produced at the power stations. So this is very much important to understand. So suppose if you save 1 unit, then you can not only saving the 2 units of the energy generation at the thermal power station. Rajendra sir, you have to mute your mic. Okay. Now you are also saving the environment. You are also saving the different aspects that I can show in the next slide, because this is the scenario in our Indian condition. This is the you can see in this particular table. This is the total power generation capacity in India. This is the latest figure from the Power Ministry website. You can see around 55% power is coming from the coal-based thermal power stations, or you can say 62% are the thermal power stations, and around rest of their renewable, hydro, and the nuclear power plants. So we can say we are more dependent on the coal and petroleum products for the power generations. So this is the trend of the you can say the thermal power stations in the capacity addition. Now if you see the coal trend in the energy or commercial sources, now you can see this is the trend in the production of energy by the commercial sources, that is the coal. Blue line, you can see this is it's increasing day by day. So you can see that it accounts 70% of the total production. Coal is dominating in the energy production. Now why this is important? Because we are importing coal from the other subcontinents, because Indian coal has the poor calorific value. So we have to rely on the other countries for the requirement of our energy generation. You can see from this graph also. So we are depending on the other countries for these particular sources. And if you see the overall petroleum products import, this is the graph. This is the monetary value. You can see this is the huge amount. It's a 0.5 million crore rupees per particular year. This is for the 2016-17. So this is very much important. We have to consider, because if we save the energy, we are also saving the economy of our country. So we are also saving the capacity addition in the thermal power stations. If we increase more, the government or the resources have to increase. And for that particular of the requirement, we have to require resources from the other countries. So this is, we have to consider in the energy conservation. That is why it is required. Now, if we see the overall energy resources availability, these are the different energy sources available with us. Now you can see in the graph, these are the renewable products, or you can say primary and secondary, whatever there are different terminologies. So these resources, that is the coal, uranium, petroleum, natural gas, these are the limited resources. Once you consume, it will be deployed, it will be consumed. It cannot be regained again, because it requires lot many years to be formed. And these are the renewable resources in the big ground. You can see the solar, wind, tidal, geothermal, hydro, biomass. This energy is available every year. If you use or if you are not using, it will be available every year. Now, if you see in this graph, this particular round, this is the total energy consumption of the world in 2015. So you can imagine how much energy we can derive from renewable energy. So if we move towards the renewable energy, or we can increase the energy efficiency, or we can save the energy, we have to we can reduce the energy losses in this particular limited resources. So we have to think carefully, and we have to optimally use the energy sources available with us. Now, these are the various steps by the government. Government is doing very rigorously taking the steps for the energy conservation, energy efficiency, and to reduce the to increase the environment awareness in the Indian dominates. These are the some, you can find it on the net. I will more focus on the practical part of it. So the Energy Conservation Act, it was published in 2001, and the different programs, that is the standards and labeling, that we are seeing the one particular star label on the particular appliances, like split AC or air conditioning or any electrical heater, water heater. You can see it on the, that is the star labeling. Based on that, you can judge how much energy it can consume, or you can compare the different products. So there are some misconceptions also I can show in my this presentation, so you can have the better idea on that. Now, the designated consumers, in that particular program by the government, there are certain industries which are highly dominated in energy consumption. So government gave some target that you have to, that is the benchmark, we can say in the our language, that is the benchmark. Suppose you have a X benchmark or consumption at this particular year, you have to reduce X percentage by next 3 years. So it will give the competition with our own selves, how we can improve by using energy efficiency and energy conservation practices. So this is the PAT program, Performance, Achieve and Trade. Then there is an energy audit and energy manager exam that is conducted by National Productivity Council. You can say it, you can see in the websites, and there are different codes, energy conservation building codes. Now, ISHRAE Ahmedabad chapter, I can proudly say that, is doing this kind of awareness from so many long years. And this particular pamphlet, full pamphlet, it was not fitting in this particular slide, so I have cut it down in two different parts. So this material is more than 10-year, I can say it is the 10-year-old pamphlet published by ISHRAE Ahmedabad chapter. So I happily put it in this presentation. So you can see the different energy conservation practices. So ISHRAE Ahmedabad chapter is also doing various activities in energy conservation and energy saving or environmental friendly programs from long time. So it's not only 2020, ISHRAE Ahmedabad chapter is doing from last so many years. So this is put up for your knowledge, and you can see and read this particular different approaches put up in this pamphlet. You can apply in your particular household, and you can save your energy. Now, these are the different instruments. This is I have shown for just for a complete idea of getting the knowledge of energy conservation and auditing. These are for your information only, so you can know which instruments are available for particular measurements. This is the temperature gun. Based on that, you can measure the temperature without touching the surface. This is the based on infrared radiation, and this is the lux meter. Based on that, you can find it the different lux level in the particular building environment. Anemometer, you can find the velocity of the air. This is the temperature and RS sensor, mostly required for HVAC&R engineers. This is the clamp meter. Based on that, you can find the different amperes and electrical measurements. This is the ultrasonic flow meter. Based on that, you can find the flow rate in the pipes. And this is the combustion and emission analyzer for the gas-based combustion processes. Now I will talk on the HVAC&R appliances, what can be possibilities in this domain. Now, why HVAC&R is important factor for particular country or entire world. You can see from this graph. If you see the energy consumption of overall building or residential, or it can be a commercial, around 30% to 50% energy consumption is only from the air conditioning. You can see from the various resources. There are a lot many resources are available on the internet, and you can check it. It will be around 30% to 50%. It can vary based on the resources and the methodology. So if you see the first graph, that is the prepared by IEA. That is a very this is the agency. It is working for mostly all countries. That is the International Energy Agency, and they predicted the energy air conditioner demand in Indian subcontinent. So you can see that there is a drastic increase of air conditioning demand in India, and so you can see the market of air conditioning. And if we not save the energy in the right way, then there will be huge impact on overall our economy, as well as the power demand in entire Indian sector. Now this is the graph you can find in Niti Aayog, that is for our Indian government, and this is also Niti Aayog website. You can see that residential and heating cooling load around 30 to 50%. It will vary from the different resources. So air conditioning demand is a huge, and we have to use this demand in an optimized way. We have to consume, we have to use air conditioner for our needs, but not in a wasteful manner. We have to use it in the proper way. Now, why this is linked? Suppose if the air conditioning demand is increased, now it will also impact the energy demand. Now for your energy demand, government or any private player have to set up the power plant. So if your energy demand is increased, they have to set up the new power plants. And if they set up the new power plant, they will either consume renewable or non-renewable. If they are consuming non-renewable, suppose for example, if they are using coal, then again, the capacity addition, and they have to invest the money for that, and then the emission from the coal thermal power plants, it will impact the environment. So this is, if you can see from this graph, in 2016, around 54% of global CO2 emission caused by the cooling, that was from US and China only. Why? Because they have the higher air conditioning demand in their particular country. You can see last two lines, US and China, and where India is standing on at this level. So, and this is the this is in 2016. So we are around here, and suppose we are increasing at this particular rate, then you can imagine how this graph will go further. So we have to careful not only the energy conservation, but the implications of the energy conservation and energy efficiency. It can be a multitude. It can various other aspects are also affecting this particular saving and all that particular parts. Now these are the key indicators: the ton of refrigerations and the kWh per TRH. TR is mostly all we know. If you don't know, you can just write it in the chat box, and you can find it. It's nothing but the unit of energy that is liberated by the 1 ton of ice. So it is the amount of heat liberated by the ice, and kWh per TRH, it is the energy consumption for the production of the cooling. So for example, if 1 kWh per TRH, that means for production of 1 TRH, it is consuming around 1 unit. kWh is in our Indian market, we also call it unit. So 1 unit, that is 1 kWh. And you can electricity utilities, for example, Torrent or UGVCL or MGVCL, they charge you on based on the energy consumption, or you can say on units, how much units you have consumed. Suppose you have consumed 30 units, so you consume 30 kWh, so they will charge you on a particular aspect. They have the matrix, and based on that matrix they will calculate, and they will charge you that bill. COP, that is the efficiency parameter for the air conditioning and the refrigerators. So higher the COP, the efficient product, we can say. So the COP is nothing but the cooling provided and the energy consumed, ratio of the cooling provided by the energy consumed. So these are the different parameters in the HVAC&R that can affect your energy saving. First is insulation. Right kind of insulation selection is very much important, and this is a huge domain. All these aspects I have mentioned in this slide, they particular themselves have its own individual, we can say, have the own presentation, and we can say in each and every topic that can be a multiple workshops can be possible in this particular topics. So this I will give just summary of that particular topics. So that is the first is insulation, that is the heat load minimization. Second is heat load minimization. Now you can say save the energy by saving reducing your heat load. You can reduce the internal heat load, that can be a process appliances, or suppose you have more human occupancy, you can, if it is poorly designed, then your heat load will be a maximum. And external, suppose if you have more glasses on the southern wall, then you will have a more heat load on your particular building. So if you can say you can plant tree on particular wall, then you can reduce the heat transfer coming from that particular direction. So this is the heat load minimization. You can optimize the heat load at your particular residential or commercial buildings. Now evaporator temperature. This is very much important. Now some people have habit of air conditioner. They can, mostly I've seen in the youth, they put it on 18 degrees Celsius or 19 degree or 20 degree. They just want to Simla, Kulu, Manali in their particular room. So they set it on 20 degrees Celsius, and they use the blankets to save themselves from that particular cold. And they will keep running the air conditioning on the 20 degrees Celsius or 22 degrees Celsius. So I will show in this particular webinar, I will show the calculations, how it is impacting on your air conditioning, your energy saving, and particular the cost, how it is affecting your financials. So this is the, if you can use the comfortable temperature without the blankets, then you can set those particular temperatures. So there is nothing to go 18 degree or 20 degrees Celsius. And they have the misconceptions that if you put 18 degrees Celsius, it will cool it fast. So that is the misconception. If you calculate, it will not going to happen in that way, on their understanding. So after this particular webinar, you can share also this webinar to those of your friends who are doing this kind of methodology or they have the misconception. You can share always this webinar and show them in the calculation that you are doing on the wrong way. Please understand technically and use it logically, whatever their understanding have. So this is also applied for the refrigerator. Some people all put it on the cool, chilled mode, the highest possible. So whether it is required or not, you have to optimally think on that particular parameters. So, and this is also affecting your energy consumption. I will show in this particular this webinar. And the load factors. HVAC&R have the different components, compressors, pump, motor, and each and every components have their own energy consumptions. And if you are not properly design it, it will consume more energy than required. So another speaker, Shivani, Soni madam, will talk on this particular topic, and she will explain how this particular selection of the pumps and motors and how VFD can help in those particular aspects, and you can save energy and you can save also financials from those aspects. Madam will tell after my session, so let it keep it for that particular session. Now I request every participant to use Notepad and either mobile they have, or you can say you can calculate with your calculators and laptop or computer, whatever they want to use. Now this is the star rating for this is the particular year for 2018 to December 2020. Now people have the misconceptions. Now let us clarify all this aspect in this particular webinar. This is published by the Bureau of Energy Efficiency, and it can vary for year to year. Suppose if you go to the buying air conditioner, some people will tell it this is 5-star, but you have to also check at which year this was labeled. Suppose it was labeled in 2016, then what happens, suppose this is the model for up to 2020 December, this model will revise next year, target will be increased. So for example, 5-star AC of 2016 can be a 3-star or 2-star AC in 2018 or 2020. You have to check it. So when you compare, you have to compare the star rating year, and you have to check this energy efficiency ratio. And based on that, you have to check it, which product is more efficient, which is more affordable. You have to check also the cost of that particular product. And this is very much important while buying this split air conditioner or whatever the energy products. This is applicable for the all appliances, electrical appliances. I am showing the calculation for the split AC, but it can be applied for any other products also. You have to just check it the star ratings year, and you have to calculate based on the requirements. Now you can see the different star levels: 1-star, 2-star, 3-star, up to 5-star, and this is the range. If the product is between this range, they will give this star. So these are the different range. Now let us calculate. Suppose we have to buy a 1-ton air conditioner, and we have the dilemma, which model we have to select. Suppose we have the 2-star AC and 3-star AC. Which model we can select? So we have the confusion, or suppose we have the condition, we are in condition, which model is the best, how to use that. Suppose I go to 3-star, the cost will be higher, and if I go to 2-star, the cost will be less, but my energy consumption will also increase. So how we can select those particular and optimize those particular aspects? So note it down, these parameters. You have to buy a 1-ton air conditioner, and which you will use 8 hours a day, and your energy consumption charges from the utilities, it's 7.5 rupees per unit, and you will use your split air conditioner for 200 days. So how you can calculate this? Anybody have idea? They can share it on the chat, or we can start it on the calculation in the Excel or whatever we can do. So what is the first step we will do? We will do what is the per unit energy consumption, or we can say what is the energy consumption per TR. So what is that? So started with this minimum energy requirement. This is the kWh per kWh. That is means this much amount of energy is required in electricity for this much amount of air conditioning requirement. So we can start in Excel sheet. Let me start it. So everybody is able to see my screen? Just confirm me so I can. Are you able to see this Excel sheet?
Yes, Gaurav.
Okay. So we have the requirement. This is the our requirement. We have requirement of 1 TR, right? So we will write it 1 TR. So you can do it this calculation. So how much kWh? kW 1 TR is equal to 3.51 kW. Now this is the instantaneous. Suppose if we use for 1 hour, it will be a TRH. Okay, so 1 TRH is equal to 3.51 kWh. Now we have two options. Which one? Just we are writing down. You can also calculate with me. So if you have any questions, we can solve at this particular webinar or in this webinar, right? So now we have known condition. I am writing on this slide. we have requirement of electricity, air conditioner, operational hours, that is 8 hours per day, and how many operational days? 200. Okay, that is 200 days per. Now, is there any other thing? Okay. Now we have this EER ratio. We are starting with this minimum, so we can calculate based on that. We have two models, 2-star and 3-star. Okay. So this is the star rating, and this is the EER. Okay. So we have model of 2-star and 3-star. Now what is the EER? It's a in 2-star it is 3.3. How many are calculating with me? Just write it in the chat box so I can know how many people are calculating. And if they have particular concerns, we can talk in that also. Just write it in the chat box so I can know and I can solve your concerns while calculating. Okay, everybody is with me? Just confirm me so we can start it.
Yes, Gaurav.
Okay, so this is EER, that is kWh per kWh. Okay. Are you able to see the fonts of this particular screen?
Yes, Gaurav, very well.
Okay. Now, what is the other parameters? Okay, that's it. Now, we have to check it for kWh per TRH. Okay, so how we can calculate it? So this ISHRAE, or you can say EER, is nothing but the cooling divided by power consumption. So how we can calculate it? We have to know the power consumption. Okay, so we have 1 TRAC, that is how much cooling? 3.51, or we can link with this, or we can write it with this 3.51 divided by how much? This one, because this is the ISHRAE, right? So we have to divide it by this ISHRAE, Indian Seasonal Energy Efficiency Ratio. So this much power consumption is required in this particular case. Now if we can extrapolate for the 3-star, it will be around 1 kWh per TRH. Everybody is clear with this particular step? You can ask it right now if you have any concerns. Then we can we have some more calculations after that. Any comments? No comments. Okay, fine. Now, what we have to calculate? Now we are using for 8 hours. So we have to find it, what will be the energy consumption for 8 hours. So per day energy consumption. This will be a kWh. Unit will be kWh. How we can calculate? This is the per hour energy consumption. I have shown in this particular, this is TRH, this is kWh. So this is per hour. So that means this energy consumption into your operational hours, right? And this is common for both the case. So let us write it in that way. I am extrapolating it for this particular, this multiply by this. This is the per day consumption. Now what will the annual consumption? Again, it will be a kWh. Now this per day consumption into number of days you are using it. So this is nothing but your per day energy consumption into operational days. Now you can also extrapolate this one. This into this. Now how much energy consumption or electricity charges per year? Okay. So you can write electricity bill or charge. Okay. So we have not wrote in this one. So that is electricity charge, that is 7.5 rupees per. Okay. Now multiply this with the electricity charge. Okay. Now suppose if you use 2-star AC, that will cost around 12,000 rupees, 700 rupees, 12,700 rupees electricity bill. Or if you use the 3-star, it will be around this much. Okay, these two columns are not needed. Okay, now what is the difference? Difference is this minus this. Okay, rupees per year. Now, for example, this AC cost. Suppose this air conditioner you are getting it 2,700, 500 rupees. This is just for example, for calculation purpose. You can have the different values based on the market availability, different websites or different suppliers. And this 3-star AC you are getting around for, let's say example, 30,000 rupees. So what is the difference in this particular? This is this minus this. Right? Now what is the payback? Suppose if you are using 3-star AC and if you are using 2-star AC, so this is the difference you are getting every year. This is the difference you are getting for using. This is the annual difference. So, and this is the difference in your purchase cost. Purchase difference, right? Now, how you can find the simple payback? Payback is nothing but the difference divided by the saving. So this much year it will pay back. Suppose if you are buying the 3-star AC and if you are going to use that particular AC for 3 years or 3.5 years, it will give the payback. It will return your money by investing more in the energy efficiency product. And the more you, suppose if your air conditioning is lasting for 6 years or 5 years, the difference of that 5 year minus this payback time, you are getting the efficient uses of the air conditioner. You are getting the less bills compared to this. But suppose if you need air conditioning for 2 years, then what will be the right way to use the investing the money? Then some can say that I have to use only for 2 years. Then why can I use the 3-star product? Then according to that, your electricity bill will be larger, but your purchase cost will be lower. So you are getting the more financial attractiveness on the 2-star. This is depending on the consumer side, how they are seeing purchasing of their product, right? So based on that, you can finding the difference in particular purchasing. Now this is not applicable for only air conditioners. You can find it various other appliances also. For example, electrical heaters, water heaters. You can do the similar calculations with this particular methodology, right? Any questions so far in this particular slide? Just I am waiting for 2 minutes if you have any questions. Okay, I have one question with if there is any calculator for inverter AC or without inverter AC, right? Now what is happening in inverter AC? Inverter AC have the different variable loads, and in inverter AC there is requirement again it is the how it is efficient, because it is not fluctuating type of it is air conditioning mode like in the conventional air conditioners. So what it do, it will keep continuing, it will give the continuous supply of the cooling as per your requirement or the set temperature. And what happened, the energy consumption for that particular temperature will be the same for the cooling load. But what is the advantage in the inverter AC? For example, if you have a normal AC and you have the inverter AC, what normal AC will do? It will try to cool down below the set temperature, and it will try to maintain it for some time. After that, it will again start, stop. So that is the energy consumption in that particular way. While in inverter AC, it will continuously maintaining that particular kind of requirement. The advantage in inverter AC is matching the frequency. VFD, madam will tell about the VFD concept, and it will help to understand why the frequency matching and all that is important in the energy consumption and saving. So that concept will be clear when madam will share her presentation. The concept will be more clear. So that particular will give the more idea on that particular aspect. Is there any question? Then I can say the last calculations and we can move to the next session. Okay, no questions so far. If you have any questions, you can just mail it to ISHRAE chapter, and then we can have some particular solution for that. Now another calculation for those of your friends who are setting the temperature for 18 degrees Celsius and using blankets to save themselves from that particular cold. So I will show that particular calculations also. You refer this YouTube link or whatever the webinar after this webinar. You can always share this particular webinar and show that this is how it will impact on your bills. Okay. Now this is the another example. Let us understand what is that particular. Are you able to see my screen? Hello, just confirm anybody. Hello.
No, Gaurav. No, screen is not coming.
Okay. Yes, I was thinking. Right. Now you will be able to see this.
Not visible.
Okay. Now this is the second example we will do. Now, what is the difference that evaporator temperature I've told earlier in this particular webinar? Now, if you set this is the thermodynamics law. If you set your evaporator temperature high, your energy consumption will be low. And what is the difference? For air conditioner, if you increase the temperature by 1 degree Celsius, your energy saving will be around 4% to 6%. This is published by the Bureau of Energy Efficiency. They have calculated on the various parameters. Now let us calculate. Suppose if you are operating your air conditioner at 27 degrees Celsius and your power consumption is this, we have seen in earlier slide, 3-star AC. Let's say this is a 3-star AC, 1 kWh per TRH, and you are using for 8 hours, and the conditions are the same, 200 operational days. And the another case is you are operating at 28 degrees Celsius. What will be the difference in energy consumption? We'll calculate it, and we'll calculate it in the Excel sheet. Let us move to the Excel. we have two conditions: operating temperature. One is 27 degrees Celsius, one is 28 degrees Celsius. Now, at 20 degrees Celsius, your energy consumption kWh per TRH is how much? 1? Okay. Now, if you are operating at 28 degrees Celsius, your energy saving will be around 4% to 6%. Suppose this is 100%, you are getting it minus 6%. So what will be the energy consumption at this level? Into, this is the simple calculations everybody can do. You can share this link to the 12th science or 10th standard student. They can also calculate it. This is the simple calculations. You can save 100% minus 6%. 6% is the energy saving by increasing the 1 degree Celsius. Okay, clear? If you have any questions, you can just write it in the chat box. I will clear it right now. So this will be the energy consumption. Now again, this will be the same. You can copy it and okay. This is the per day. Then you can have to multiply with the 8 hours. Okay. Then annual multiply by 200. Just then electricity charge into multiply by with this power consumption. Okay, this is not required. We'll move it. Okay, now what is the difference you are getting? This minus this. This much rupees you can save in year. Suppose if you are using air conditioner at 27 degrees Celsius for 8 hours a day and 200 operational days in a year, then your energy charge will be 12,000 rupees electricity bill. Suppose if you are operating 28 degrees Celsius at the same conditions, your electricity will be around 11,280 rupees. So this much you can save by increasing 1 degree Celsius. And I can proudly say that ISHRAE Ahmedabad chapter has a very well-known platform that we have the awareness campaign that is known as 1 degree campaign. In that we are keep spreading about this particular factor, and we have the we tell them that by setting the temperature above the 24 degrees Celsius, you can not only not saving your electricity bills, but you can also helping the nation in the environment also and in the power consumption also. Now, very interesting factor is, this is the calculation we have done for 27 degrees Celsius and 28 degrees Celsius. Suppose if you do for 26 degrees Celsius, 24 degrees Celsius, 18 degrees Celsius, then what will be your bills? If you go in this downward direction, your bill will be reduced. And if you go the upward direction, your bill will increase. I am just putting it for your homework. You calculate for 24 degrees Celsius. Just go one by one, how much energy consumption increasing in each temperature, and you will get to know by setting the temperature at 22 degrees Celsius or 18 degrees Celsius, how much energy consumption your energy consumption is increasing. Just give this particular task to those of your friends who are keeping the temperature on 80 degrees Celsius and sleeping with the blankets. So save those this particular slide and this presentation, and just tell them to calculate about the power consumption at those particular temperature. With this, I can just keeping your thought process open. Suppose if you save energy from your particular house, then you can think that by saving energy in your house, then if your society can say, this is the larger perspective. Suppose if you are doing by yourselves, then society, then city level, then state level, you can see the multiplication effect of all this saving and the capacity reduction in the power demand, overall power demand of the country or the state. Then based on that, you can see that how much coal consumption is reduced or how much environment saving is reduced because of the low power demand and the lower power plant capacity addition. I am just keeping this thought process open in your mind. It will keep thinking on this particular topic. And thank you very much for listening with me passionately in this particular talk. And these are the resources. You can refer it in the future for learning more on this particular topic. And now let us, I invite Madam, Shivani Madam, to talk on her session on the VFD. And if you have any question, you just ask in the chat box, or you can later on you can communicate with the ISHRAE chapter. Thank you very much.
Thank you, Gaurav. It's a really good session and you have done it very interactively.
Thank you, sir.
I request Prashant Bhai Pathak, President of ISHRAE chapter.
Yes, sir. Good morning, all. Gaurav bhai, you were amazing and absolutely fine on creating the awareness of the energy conservation, and you have done a fantabulous job by showing a great example and making the live calculation on how the power consumption can be saved by just increasing 1 degree, and that is exactly what ISHRAE chapter is doing while promoting 1 degree campaign. And thanks for promoting 1 degree campaign, and I would definitely urge all the people listening this video or live webinar to raise that temperature of their AC by 1 degree and contribute to the energy conservation on this day of Energy Conservation Day. Going further, I am pleased to welcome Ms. Shivani Madam. She is mechanical. She is a master's in electronics and communication, and she has worked in various fraternity of engineering, which is instrumentation, automation, power industry, and electronics engineering also. So without further ado, I would request Shivani Madam to take it over and give us a glimpse on what is all about in energy conservation through Vfd Drives. Over to you, Shivani Madam. Thank you very much for being with us, and please start your session. Thank you.
Thank you very much, sir. Thanks for giving an introduction. Everyone can see my screen?
Yes, ma'am.
Okay, fine, sir. So, thank you very much, Mr. Gaurav Patel, sir, who are giving a very informative sessions regarding energy conservation. Today, I just give a simple energy conservation approach using the VFD, how the VFD is used to save the industrial power consumptions. So we know that in the global warming, the temperature is day by day is rapidly increasing. So the energy demand is also increasing, and the economical growth of the power in India, the power consumptions is also increases. So we have to try to reduce the maximum demand. So how to reduce the maximum demand as per the calculations? The maximum demand itself, that is the peak load and the reciprocal of the power factor. So if we control the power factor near to unity, we can definitely reduce the maximum demands. In the industry, we see that the machine drives is very significantly by the using the electrical drives phenomena. So here that there is the different ratio of the different manufacturing industry where they are using the drive electricity. On that, the maximum area of concern to getting the maximum power consumptions are for that in the pump and fans and more on the compressor side, so that we see that the industrial motor energy, it will be used the maximum power consumptions. right? So how do we reduce the power consumptions of the motor? We see that the costing of the running motor, around the 70% of the energy it will be consumed by the motor in the electricity, and the other are for the maintenance and the investment purposes. So that if we control the 70% of energy consumptions which are getting from we are getting that are getting from the motors, so we definitely control the power consumptions of the industrial era. For that we are using the VFD. You know, the you might be you are aware about the terms VFD. VFD is the variable frequency drives. It is also known as the AC drives or the adjustable or the frequency drive. The working principle of the VFD is that you can control the speed with the help of the frequency. So the synchronous motor, it will be directly proportional to the frequency which are applying to the motor, and it is also depends on the poles of the motor. So that in the mainly when we are needed to the change the speed of the motor, basically for the pump and fan applications using in the HVAC and the power industry, the VFD is a very important equipments which are control your speed. So using that, we are definitely control our power. We see one block diagram of the VFD, how the VFD is work. Basically, in the VFD circuits, they are providing the three-phase line voltage, which are operated with the 50 Hz frequency. On the VFD inside, there is electronic devices are there which are rectify your input voltage and converted that AC voltage into the DC forms. After that, using the higher switching devices like the IGBT, that will be converted further your DC power into the AC form. So there is an inverter inbuilt in the VFD systems which is converted your DC power into the AC form. That AC power, it will be converted into the PWM form, so that we can control the frequency. PWM means with the pulse width modulations frequency range we are getting from the fixed frequency to the variable frequency. So that variable frequency power we are applying to the motor. So according to the frequency range, as per see the working equations of that, if we change the frequency of the supply voltage, then we are changing the speed of the motor. If we change the speed of the motor, we are consume the power. We are also consume the power more or less according to the speed. So let's see the one examples of how the VFD's role affected on the power consumptions for the industrial. There is a flow applications and where they are using the pumps of the 15 HP or the 10 HP pumps as provided. If we are using, we are not using the VFD, then we see that the number of losses, generally that the mechanical throttling valve is used for the pump applications, so that there is a number of losses we can calculate here. So around to operate the pump at the 100% flow, we are required the 90 HP motor is there. Now instead of that, if we are if we are employed the VFD in the systems, if we are control the motor with the VFD, so we have to just neglect that control valve, so that there is a losses of the control valve. It will be the mechanical losses is also will be reduced in the systems, and we see that around the 70 horsepower is required to running the motor at the operating of the full speed of the pump. So here the we can say that nearly about 20 to 30% of power consumptions we are reduced while using the VFD. So this calculation is based on the energy consumptions of the affinity loss. Basically in the fan and pump applications, the flow or the volume is directly varies with linearly with the speeds. So in the there is a two or three statements for the affinity loss are there. If the flow is increased, speed is also increased. If the speed is decreased, your flow it will be decreased. So same way, if in the pressures or the head pressure is varies, the directly that will be that will be proportional to the square of the speed. And the power consumptions or the energy consumptions is varies, that is the cube of the speed of the motor, so that we can say that the 10% reductions of the speed gives a 25% of saving in your power consumptions. So that here we can see that in the graph, that is for the linearly proportional of the flow with the speeds. When we are the pressure is the square root of the speeds, and the power consumption is the cube of the speed. So that in this example, we can see that at the 90% of the speed that is required, the 70% of the 70% of flow is there. So here gradually it will be, if we increase if we reduce the speed of the motor, then gradually the flow it will be reduced, and then we are getting the maximum power consumptions over here. So if the motor is running at the 90% of the full speed, we require the 70% of electricity at the full load. So here there is around 20 to 30% of power consumptions are there, which is very useful to consume the power. Now see here that in the conventional flow method, we use generally the flow control valves. In that control valves, there are a number of losses are also there, and there are energy losses. The mechanical and electrical losses are affected on the systems. Instead of this conventional method, if we are using the VFD, we see that we have to just remove the control valve over here, and using the pump or fan, it will be controlled by the VFD motors, so that we are save the energy for the energy as per the power consumptions. Now the potential area of the energy saving in the industry are basically the fan, pump, and the compressors are there. So that in the fan control, if we are using the conventional method of the fan, then we are using the damper controlling. We have to control the damper opening and closing. For that, if we are using the VFD, so we are getting the 20% reductions on the speed. We are getting the 50% energy savings. If we are reduce the 20% of speed of the motor or the fan, then we are getting the 50% of energy savings. And also we are same calculations for the pump also. In the pump, there the two methods are used generally. For the throttling valves are used, or the venting or bypass valve we are using for the conventional methods. But instead of that, if we are taking the VFD in the system, so we can say that the same way that we are reduce the speed of the motor, and then that will be control the fan speed, control the pump speed, and we are getting the 50% of energy saving here. And on the same side, the VFD have a features that that will be there is a PID controlling parameter. PID controlling parameters are also there, so we can utilize that into the process systems. So basically for the fan and pump applications area, for the ID and FD fan which are used in the power industry, the HVAC system, the AHUs are that, the cooling towers and the blower systems, the fan are controlled by the VFD. We are getting the maximum power savings over there. The same way in the pump area, there is a service water pump and a chiller pump. In the pressure boosting or the primary or secondary pump, we are using the VFD, and we are getting the power consumptions. We are reduced the power consumptions of the motors. And the additional features of the any additional benefits of the VFD is that when we are required to operate the full load conditions of our motor, so that time the torque will be increased rapidly, and that time suddenly the energy consumptions of the motor, it will be increasing. In the VFD, there have a facility for the soft starting. Soft starters are provided on that, so that there is a soft starting applications are also inbuilt in the VFD. It is also used for the high starting torque, and the efficiency of the motor, it will be also increased while using the VFD, because the varying and tear methods, it will be very reduces of that. obviously the payback within 12 to 15 12 to 24 months we are getting back, because of the, as per the duty cycles, we have reduced the energy consumptions. If we reduce the energy consumption, we are getting the more payback in terms. Now the flexibility control is also that, because they have a PRD controller, there are also there are so many monitoring parameters are there. There is also protections relay are provided on the VFD systems, and it is also interface with the other control systems. So if we have to use the VFD in the industrial era, we can definitely control our power consumptions for the today's industrial automation sites. So thank you very much to all of you for hearing me. If you have any doubt, please ask me on the chat box. Sir?
Yeah, madam, thank you very much for giving a very detailed insight in the very short time. Looking to the constraint of the time, we couldn't cover much, but I think you were very informative and quite to the point to explain the agenda or the subject to the all audience. And thank you very much for being with us. Hardik, would you please take it over? Hardik, are you there with us? I think he has got some issues, or else he's visible there, but he's not listening to us for some reason. But thank you, Gaurav also, and Shivani madam put together. You have made the today's day very memorable, because as you know that it was energy conservation day, and you have touched the right subject on the right day. And thank you very much for giving a very great insight to all the students or the members or the audience. And this is going to be live. This video is going to be available in our YouTube channel also, so people will see it later also. So that's a great thing which Ahmedabad chapter is also doing. But thanks for giving a great content. And Gaurav and Shivani, a special thanks to you. Reason being that you have given this confirmation of program in very short time, and thank you very much for that. I know that you people are too busy, but when it comes to IAC, when it comes to giving back to the society, you are always there to support us, and thank you very much for supporting us once again. Rajendra bhai, I am concluding the program, and
Yes.
we can
Just one line, sir.
please,
Thank you
sir.
very much.
My pleasure.
Thank you very much for providing this platform. And the idea behind the calculation is that later on people can use it, because we have seen the tendency in youth that using the air conditioner at 18 degrees Celsius or 20 degrees Celsius. So my motive was to make them aware, because everywhere I cannot reach or you cannot reach. So YouTube can reach with youngsters in their mobiles, so they can later on share, and they can have the awareness on the energy savings with the air conditioner. So I just thought yesterday morning that this should be there in the content. So I just keep it the change in the presentation.
It's a really nice initiative and nice idea by you, because let me tell you and accept in front of everyone that many of the even industry dealers and people are also not aware that how to calculate the consumption and how to calculate the difference or cost difference between two star ratings, because many times the dealer and the people who are into the trade are coming across this question that which machine should I buy, and when they are encountered with this question by their customers, I know that many of the time people fable. They do not have answer, and then they go by the commercial aspects rather than explaining them in detail about their requirement. And in case if somebody does this, it's only one.
Sir, your audio is
There is pause.
some problem is there.
Some internet issue is there.
Yes. Yes, welcome back, sir. Some internet issue.
Yeah, so that is what I think, that when they come across such questions, it is better. It takes only 1 minute to give this calculation to the customer. But in case if you do means if any trade person does this, I think he can not only win the deal but also win the heart of the customer, because that is the information is required by customer every time. And in case if you educate them, you win the customer forever, because then that is the right information you provide them, irrespective of the brands and any commercial equation. This is the right thing one should do, and that only will promote the energy conservation. We being the volunteers or the warriors of conserving energy, this is the right tool you have given to all of us to empower our own self while fighting against the energy conservation. And thank you, Shivani madam, once again for giving an insight about using of VFDs in different HVAC applications. For some reason, I had some issue in my technical, in my corrections, but surely I'll go through once again through YouTube channel, and I'll get the entire gist of the program. Thank you very much, madam.
Thank you, sir. Thank you
Thank
very
you.
much, sir.
Thank you, ma'am.
Thank
you, Gaurav.
sir.
Thank you.
Thank you, sir.
Have a good day, all of you.
Okay.
Bye.
Bye.